Hi, good day. My name is William T. Dongo, your professor for today. Well, I use this as a Mr. Dongo, as just like I'm a real professor now on my being an instructor for this air conditioning and refrigeration technology. I am a licensed California teacher. Used to be. I had my adult school teacher license and a credential, but now I retired, so I just do present this lecture to you guys to help you if you decided to go to this field or to enhance your training. Okay, I always follow the philosophy that when I worked with the big airlines, this 65 years old man told me, you follow me, because I'm gonna retire soon, and then you're gonna get all the information that I learned in experience that is stuck in my head, because what I had experienced, you're gonna find it in any book. So I try to pass the same tradition to these by giving my works experience since I'm retired already through these videos. Okay, so the one we're talking about today, again, we will continue on the climate control and refrigeration technology, residential and commercial air conditioning, continuation of lesson 4, which one we continue on. The lesson will be lesson 4A, electrical system and components. Today, the next subject we're talking about is troubleshooting. The pre-checks, starts relay, start capacitor, run capacitor, capacitor general information, rules for sustaining capacitor, relays for contactor, fan motor, starting motor, component problem, motor, compressor, tolerances for three-phase motor, and then motor protection and general information. So I'll be reading here now, giving you the information on the troubleshooting electrical. Okay? Pre-checks. There should be 5 basic steps done before beginning troubleshooting electrical. They got check air filter, okay? Check the thermostat, check for line, high voltage, check for controls, usually 24 voltage, okay? Get the fans working first, okay? Those are the things that you can go before you go to any deep troubleshooting. The preceding is a handy references section to quickly pinpoint the trouble and cause. Okay, the first one we'll be looking at is the start relay. Start relay will not open contacts. Voltage is low. Start capacitor burn out or wrong one. And then run capacitors burn out or wrong one. High head pressure. Start relay burn out or wrong ones, and then compressor burn out. Okay, will not close the contact, relay burn out or wrong one. Okay, and then burnout is an improper wiring, voltage is low, high head pressure, start capacitor burn out or wrong one, run capacitor burn out or wrong one, low suction pressure, and the compressor burn out. And then the start capacitor. The start capacitor, you got an open circuit, not effect. Capacitor check okay. That's improper wiring, loose connection or broken wire. And then you have a wrong size. Wrong size must be sized along with other starting components for particular compressor being used. And then you have a burnout. Burnout, okay, improper wiring, run capacitor, burnout or wipe, wrong one, I head pressure, and then compressor burnout. And then the run capacitor. Run capacitor, open circuit, same as start capacitor. And then you have a wrong size, same as start capacitor. And then you have a burnout. Voltage is high, okay. And then we're gonna discuss about the capacitors, the general information about capacitors. Be sure you select the right capacitors for the right equipment as designed. A shorted run capacitor usually bulge, okay. A shorted capacitor will blow out the small disc on top of capacitor. Run capacitors are designed to remain in circuit all the time. Start capacitor has to be removed from the circuit in a very short time, usually 1 to 3 seconds. Capacitors are usually wired in parallel when needed. Total capacitance is the sum of both capacitors. Only 1 horsepower and larger use 15,000 ohms to 20,000 ohms 2 watts bleeder resistor. Wire across the start capacitor terminals prevents excessive relay contacts arcing, okay. On some AC unit with a 1.5 pole contactor, the run capacitor will have a resistor to meter a small amount of current to the compressor to act like a crankcase heater. Dual run capacitor has 3 terminals. Terminal marked as H or COMP for compressor, F for fan, and C for capacitor common to both H and F. H is wired to compressor start terminal. F is wired to fan motor start terminal. C is wired to run terminal of both the compressor and the fan. Okay. Most run capacitors have the outside foil identified. A raised dash mark, a red dot, some types of mark or identification. Identified terminals must be connected to the compressor run terminal. On the PSC motor, the run capacitor is sized to perform as starting capacitor as well as a run capacitor. A run capacitor will have a metal casing. A start capacitor will have a plastic casing. What is the rules for substituting capacitors? Substituting capacitors, voltage, okay, either capacitor, the voltage must be equal to or higher than the one being replaced. Run capacitor. Capacitance valve cannot extend plus or minus 10% of the one being replaced. And then you got the start capacitor. Capacitance value can either be equal to but not greater than 20% of the one being replaced. And then you have a relay or contactors. Okay, relay or contactors will not pull in, no harm. Open control contacts. Improper wiring, open circuit, burn, or open coil. And then the one will not pull in, and then it arms. Voltage low, shorted coil, and then your armature is sticking. Contacts burn, okay, voltage is low, overloaded, armature sticking. And then we're gonna go with a fan motor. Fan motor troubles will be fan will not run, no voltage to motor, loose connection or broken wire, internal protector open or bad, will not run, hums cut out on overload, run capacity burnout or wrong sizes, motor burnout, motor bearing seize, okay, and then run cycles on overload, blower motor overloaded, voltage low, overload bad, motor mechanical dragging, okay. And then you have a starting components problem. That means you got starting motor, starting components problem. Just like it means it don't start, period. Okay. And then if it's starting components problem, you got running capacitor open, motor may or may not run. If it run, the current will be higher than normal. And running capacitor shorted. Overload will trip because potential start relay and start capacitor short out of the circuit. And then you got the potential start relay points stick close. The start capacitor stays in circuit. Draw high amperage, trips overload in about 10 to 30 seconds. Compressor will start but run with a loud growling hum. Eventually, start capacitor will blow out. And then you got potential start relay points stay open. Compressor will hum, try to start but not run. 15 to 20 seconds overload will trip cycling compressor off. This will continue to cycle on and off until repaired. And then you got starting capacitor shorted. Will draw high amperage, internal potential protector will trip. Good possibility start capacitor will blow up. Starting capacitor opens. Problem is starting capacitors open. Compressor will run like a PSC motor if it were not to start, okay. And then the next problem will be incorrect voltage to potential start relay coil. If relay has been changed with one having higher operating voltage or longer contacts opening times pick up. Most will run too high speed before contacts open. Very noisy motor, wiping and breaking of compressor parts. Ruptured of the start capacitor. If relays is changed to one of the lower operating voltage or shorter contacts operating time pickup, okay. Relay will open before 75% of full speed is achieved. Motor will stall and drop back in speed, causing rapid cycling of motor speed. Rapid opening and closing of relays contacts, okay. Eventually burning out the contacts. eventually burning out the start capacitor. Never replace a potential start relay with one of difference. Very important. Operating characteristics. Okay. Motor compressor. The motor compressor. Motor compressor will not run in no amps. Open contactors, overload strip, improper wiring, refrigerant shortage. Okay, the compressor motor will not run, humps, cycle on overload, improper wiring, voltage low, start capacitance burn out or wrong one, run capacitor burn out or wrong one, start relay burn out or wrong one, and then high head pressure, and then motor cease, and then starts capacitor stay in. Then you have improper wiring, improper size potential, start relay, voltage is low, run capacitor bad, start relay is bad, high head pressure, and then you got your compressor like mechanical drags. Mechanical drags, that means something is rubbing. It starts and run, and it cycles on overload. You got improper voltage, run capacitor bad, high or low voltage, compressor mechanical drag, and then improper size potential, start relay. Okay, now we'll be talking about tolerances for time phase motors. Okay, tolerance for 3-phase motor. Sorry about the first one that I said. The real word is tolerances for 3-phase motors. The first one is voltage. Must be within plus or minus 10% of rated voltage. Okay, voltage phase unbalanced. Never run a motor where greater than 2% voltage phase unbalance exists. And then you got the resistance. All 3 windings should indicate equal resistance within 2 to 5%. Current draws. Current draws should not exceed 125% of the nameplate, that's FLA, when unit is operating. Current unbalance should not exceed 10%. That means you take the 3 legs and then you put your ammeter, and then you can draw your current pool in there. And then you have the motor protector. Motor protectors are designed to open the electrical circuit to motor if it draws too much current, overheats for any reason, or if becomes too hot. By metal this type. You get 2-terminal type mounted on shell or dome of compressor in series with compressor common, reacts to excessive current and heat, can be referenced to the as a 2-term click-on, can be referred to as a 2-terms click-on, okay. 3-terminal click-on, usually installed on a CSM motor. In case potential start relay points fail to open and rip out start capacitor, high amps draw will occur, which will heat heater coil between terminals to entry on the protector, cause bimetal switch between terminals 1 and 2 to open breaking line voltage. Okay, we're talking now about 3-phase motor. Motor internal protector, used mainly on hermetic compressor, normally open when temperature reaches 200 degrees to 250 degrees. general two type. You got the bimetal disc and series heater coil, and you got the thermistor installed directly on or in the windings. Depending on ambient temperature, it may take 1 to 2 hours for the protector to close if it open. General information: best way to check a fuse is to remove from circuit and use a ohmmeter. No power applied to the set of the contacts using an ohmmeter. There should not be any resistance. The number one reasons for coil failure is the improper voltage. Transformers are rated as by the VA, voltage amps. Compressor must be cooled before 115 degrees, okay, before making continued checks. Ensure internal protector is closed. Never jump across the compressor terminal of an internal thermostat. When disconnect power, lock the power switch open. Prevent someone from accidentally closing the circuit, or closing the circuit and you're on the other end that you're working on it, but you put a lockout tag out and somebody turn it on. Think you're gonna be a fried human being, ladies and gentlemen? Tag the switch to warn other people. Each manufacturer that uses a circuit board has checked out procedures that they recommend. Okay, that's the end of this chapter. I think this thing got a lot of information about the troubleshooting of the electrical component, the relay, the transformer, the motor, and stuff like that. But remember, be careful working with electricity, and then try to follow all the safety procedure on electricity so that you won't be electrocuted. Again, this is the end of the lecture for this chapter 4A. Then this one is for training purposes only, and then I'm not liable for if you got electrocuted or not. And I thank you again. Bye.